morning, everyone. My name is Ivy, and my topic is the Hamburg penguin, which have a tarsal supreme biological heat exchanger. And these are the authors. The paper is from the Journal of Thermobiology. This is the Hamburg penguin. It is a medium-sized penguin. It weighs 56 to 70 centimeters long and weight of 3.6 to 5.9 kilograms. And then it has a white border, this one, around its face. It made us easy to recognize. The distribution of Hamburg penguin is around the coast of Chile and Peru. And the physical data of the Hamburg penguin, like their height and weight, is from Stanley Park Zoo in Canada. And my purpose is to tell you that the wrist have a tarsal. I will call it RT later. It's important to penguin. What is the RT? You can look at this picture. It shows the penguin's leg. The arrow is the flowing weight of the blood. The artery brings the warm blood which flows from the heart to the leg and make the core environment. The blood will be cooled down and flow back to the vein. And this part is the RT. It is an intermingled network of artery and vein. The core blood will be warmed up in RT. The RT forms a biological heat exchanger. The core blood will be warmed up before it flows back to the heart. That's how the penguins keep themselves from losing too many heat in cold temperature. The author compared the human-like vessel model with the penguin RT vessel. And you can look at this one. This is the human-like penguin leg. Here don't have RT, so the core blood will not be warmed up before it flows back to the heart. In human case, the temperature difference of heart and leg tissue is 3 degrees Celsius. The distance is 0.5 meters. And the ratio of delta T and delta X is 6 degrees Celsius per meter. In penguin case, the temperature difference of artery and veins in RT is 10 degrees Celsius, and the distance is 0.005 meters. The ratio of delta T and delta X is 20,000 degrees Celsius per meter. So the penguin need to develop RT to do a more efficient heat exchange. This picture shows the leg temperature distribution. This is the Hamburg penguin leg model, and this is the human-like penguin leg model. When the blood which flows into the arteries is 38 degrees Celsius, and it becomes 1 degree Celsius after it flows back to the vein. The Hamburg penguin model will have around 20.35 watts and with RT, and the human-like model only 9.05 watts. Watt means the speed of energy transport. So the RT is more efficiently on heat exchange. And this picture shows the metabolic heat conservation. And you can look at y-axis. This shows the temperature which flow in the bed, and the x-axis is the efficiency discrepancy. It is the total heat exchange difference of penguin model and human model, and normalized to the total metabolic heat production. And you can look at this point. When the blood which flow into the arteries is 38 degrees Celsius, and it becomes 1 degree Celsius when it flows out of the arteries. The inlet temperature difference is 37 degrees Celsius. And you can look at this point. When the blood which flow into the arteries is 25 degrees Celsius, and it becomes 10 degrees Celsius after it flows out the arteries. The inlet temperature difference will become 15 degrees Celsius. And you also can look at the y-axis of this picture. This point, the efficiency discrepancy factor is 65%, and this point, the efficiency discrepancy factor is 25%. And we can, I forgot to tell you that the efficiency discrepancy factor, we can consider it as metabolic heat conservation. So we can know that the larger the inlet temperature difference is, the more heat will be transferred from the arteries to veins. So the efficiency discrepancy factor will be higher, and the metabolic heat conservation will also be higher too. And this picture also tells us that the penguin RT can contribute to 25 to 65% metabolic heat conservation. We can show us here and here, from here to here. And you can look at this picture. The red tells us the temperature is higher, and the blue tells us that the temperature is lower. And this is the penguin neck model. And here we make enlarge it. You can see here have a red spot here. So the picture tells us that the many heat transport is happen in the proximal part of reed. Proximal means closer part of reed. So we can know that the RT normally isolates the fluid from the body quite well. And these are my conclusions. First, RT is more efficiently on heat exchange and help to keep more heat. Secondly, the penguin RT can contribute to 25 to 65% metabolic heat conservation. Third, the RT thermally isolates the food from the body quite well. So I can tell you that the reed hypotoxic RT is important to penguin. Thank
you. Okay. 30 more minutes to make 30 more seconds to make 10 minutes. Sorry. Okay. Good. Q&A. Wait. Louis. Yami. Joyce. Okay, in this order. Wait.
And can you tell me why doesn't human develop RT in your opinion?
Repeat this question.
Why I think the human didn't develop RT? Because RT help efficiently heat exchange, and the penguin live in a very cold temperature, and human not, and human so the penguin need to develop RT. I think because the habitat is different.
Okay, Louis. Repeat the question.
Does there any other animal have RT which live in the polar district? RT also happen in the birds.
They are birds.
I only think of penguin, and some birds live in, some other birds live in.
Okay. Yummy. Repeat.
Why the human life delta x is 0.5 meter and the penguin life delta x is 0.0005 meter? The author didn't mention this in the paper, but I think we also want to discuss the RT of the penguin. So the author used the distance between artery and vein in penguin RT here, and use the heart and neck tissue in the human test. And because the human didn't have RT, and I think so that this make this number so small and it's so big.
Okay. You try. Okay, Joyce.
In so many topics, why do you translate
Repeat.
Why I choose this paper? Because I have read this topic in one of my class. Ocean animal research, and I think the read Tabatasio is very important, very interesting topic. So I choose this
Okay, volunteer question. Any? One, two. Okay, Casper and Eric.
Can you turn to page 10? I want to ask why do you draw the diagram on the right side? I mean, what does it mean? Yes.
Oh, this one is made by Excel, and this one is made by MATLAB, and this one is a 2D picture, 2D graph, and this one is the 3D graph, and it shows us three numbers, and this one only shows us two numbers.
I mean, why do you need to add one more number?
Because I think maybe I will use it in a question, and it has a contrast. Make this point to become 3D and make the number more clearly. You can see this point, the arteries is 38 degrees here, and this point, the arteries temperature is 25 degrees.
Okay, move on. Eric.
How did you get this data?
I don't get your question. You say this degrees?
How? Yes. I mean, what is your vessel and materials? And how did you get this data?
Oh.
You need data to research.
The efficiency discrepancy is count with the heat exchange of penguin and heat exchange of human.
Alright, I see that you didn't answer his question, and I will help to clarify that point. Okay, my turn. Okay. So, okay, I will first say something good about the presentation. So, the presentation itself explain the results and discussion very nice. I say so because I roughly browsed through the paper. And if you have seen the paper, you will see how much she has simplified it for you. This one's first, right? You will see equations. Alright? So it's actually not a very easy paper. Okay. So it also took me some time to read it. Alright. So she simplifies it a lot so that it's understandable for you, which is very nice. However, the main weakness of the whole presentation is you, in a study like this, it is a modeling study. 数值模拟的研究. In a modeling study, it's very different from an experimental study where you go out and collect data on your own. In a modeling study, you just sit in front of your computer and construct your own world. Okay? So in this case, you have to explain well how you come up with this model. Can you look at this? This is your model, right? But this is already results. Okay. This is not the procedure of how to make a model. And therefore, that's a sort of answer Eric's question. I think in your next your talk too, you need to explain this figure. the whole figure. You can see there A, B, C, D, E until I. In this figure, the authors are trying to explain how they set up the model. Okay? You have to explain it in a very easy way. Do not go into detail. Okay? Yeah. However, you can see that actually in the computer, the author used some software to simulate the leg of a penguin. That's what they did. And then they gave some parameters, and then the model started to calculate. That's the reason why she has a lot of data. But none of them are experimental. All of them are modeling, model results. Okay, so that's the main weakness of your talk. You have to do that. Okay, and then another thing that's related to Wiwi's question is, I think a minor weakness of your talk is the introduction is not enough. You just tell us about the penguin and RT, right? However, as Wiwi asks, why penguins have RT? So at the beginning, it would be great if you say something about their harsh environments. That's the reason why they need RT, and especially why they have RT in their leg, not other parts of the body. Okay, so we know that your legs, your distal, your fingers, your legs are very sensitive to cold temperature, right? So that's the reason why they need RT. So these are my main comments. Okay, now come to the minor comments. Okay, how do you call this part? This part. This part. Good. How many of you know this word, intermingle? So you have to explain this.
Intermingle means tangle.
Okay. Or sometimes you can just say like a twist, twisted, use your pose like this. That means intermingle. Okay? Good. And later on in your results, you explain. So what's this axis? Is X or Y?
The author explain what is the x-axis.
Okay, so this is x-axis, and this is y-axis, because you were thinking as a point of your talk. Is this x or y? Okay. So, and then in your presentation of your results, you introduce the axis, but here you don't, so you have to explain a little bit. Yeah, I know you introduced the x-axis with this, but you did not tell us what's your y-axis, so it's temperature. Okay, so how do you read this? Let me just call one student. Ruby, how do you read this? 20.35. Okay. How do you read this? Discrepancy. Okay. Okay. And then I know that you explained some efforts to you spend some effort to explain what's EF. Yeah, right? However, to me, it's not very clear. A higher EF means the energy from the artery, mind, is well conserved in the body or distributed to the muscle. Which one? A higher EF. You have to answer that next time. Okay, you can check the video later. I asked this question. Because you say, oh, that means higher metabolic heat conservation, but what does that really mean in a simple way? Where does the heat go? So the heat just go back to the heart, or it's distributed to the muscle of the leg and foot. Okay. So that's my major comments, but overall I think it's a very good talk, but the material and the model construction part needs to be added. Okay, let's thank Ivy again.